So it's recording. Oh, always forgot. Alright, so it's recording now. Okay, substance A and B. Untuk redox titration is a process of transferring of electrons. So substance A here will transfer one of its electrons to substance B. So this will undergo oxidation process, and this will undergo reduction process. Okay, so this is where the term comes from. Redox is the combination of reduction and oxidation. So untuk proses oxidation, it means any substance that lost electrons. Kalau reduction, they gain that electron. And kat sini saya highlight, both processes are complementary of one another. So itu bermaksud dia mesti berlaku serentak. Elektron ni daripada A dia akan goes to B. Dia tak akan goes to any other substances that is not involved in the reaction. So one example of redox process adalah proses the rusting process, proses karat. Kalau kamu ada any metal exposed to air and water, the electron from the iron Fe. Okay, metal, iron is a metal. So bila dia terdedah kepada oksigen dan juga air, dia akan transfer electrons from itself to oxygen. So dia akan menghasilkan iron oxide. Iron oxide adalah besi yang karat, yang rapuh, yang warna merah. Okay, so this is an equation yang saya nak tunjuk, saya nak highlight. The transfer of electrons from iron to oxygen. So take a look at this half reaction here. This half reaction. Don't get apa nama, jangan tengok yang lain lagi. Okay, tengok yang this first one dulu. So in this first half reaction, kita fokus on iron saja, on Fe sahaja. Okay, so in this case, kita tengok, dia kata kat sini Fe, this one produces Fe3 plus 3 electrons. So dalam chemical equation, it is important that you know, kita tak tulis negative notation, kita tak tulis minus. Everything must be in positive notation. So this plus 3E here means this iron ferrum ni kehilangan 3 elektron. It means Fe tolak 3 elektron, producing Fe3 plus ion. Okay, so biology also, if you remember, if any substances lost electron, it will become more positive. Okay, so remember my analogy dulu. Kalau saya lost, kalau saya tinggalkan one bad habit, saya akan jadi seorang yang semakin positif. So saya apply that logic to elements. Bila dia lost one electron charge dia adalah negatif, dia akan jadi semakin positif. So kalau satu ion kehilangan satu elektron, dia akan jadi Fe plus. Kalau satu ion kehilangan 2 elektron, dia akan jadi Fe2 plus. Kalau ada kehilangan 3 elektron, dia akan jadi Fe. That's why kat sini, this is the equation that shows that iron here lost electron. So in this case, kalau dia kehilangan elektron, iron undergoes oxidation process. And oxygen here receive that electron. So they undergo reduction. Don't worry about the number here 3, 4 because ini dia belum balancekan lagi the equation. So in the end here dia dah balancekan lah. That's why dia darab 3, dia darabkan 4 kat sini. So don't worry about the math, the balancing equation right now. Just understand that siapa yang hilang elektron, siapa yang gain elektron. Okay, that's the important thing yang saya nak kamu dapat from this slide. Okay, saya nak kamu faham what is reduction process, what is oxidation process. So siapa yang, for you to understand that, kamu mesti tahu siapa yang lost electron, siapa yang gain electron. Okay, so apa nama, this is an example, an application of redox titration. Okay, So titration example, the estimation of ferrous ion. So if we have a tablet, if we have a pharmaceutical drug that we want to estimate, kita nak tahu berapa banyak amount of ferrous ion yang ada di dalam ubat tersebut. So we can perform redox titration. So we can titrate it with steric ammonium sulfate standard solution. Macam dalam example ni. What happens is kalau kita titrate ferrous ion ni, ubat yang ada ferrous ion dengan steric ammonium sulfate standard solution ni, the ferrous Fe2 plus here akan bertindak balaskan Ce4 plus. Ce ni steric lah, yang ada dalam steric ammonium sulfate tu. Ferrous ion yang ada dalam ubat kita tu, this is Fe2 plus. Okay, so kalau from this equation, macam mana kita nak tahu siapa yang oxidize, siapa yang reduce? Iron ni oxidize ke reduce? Steric ni oxidize ke reduce? So to understand that, kita tengok at the half reaction. Sama macam ini tadi, kita tengok at the half reaction. Half reaction meaning kita tengok just at one ion sahaja dahulu. So dekat bawah ni, so kita tengok dekat ferrous kat sini, Fe2 plus. Okay, so dekat sini, in this case, saya tulis Fe2 plus jadi Fe3 plus. Saya ambil from this top equation saja. On the left hand side dia Fe2 plus, tapi on the right hand side dia jadi Fe3 plus. So kita nak faham, kalau kamu dah nampak kat sini the changes in the oxidation state, Fe2 plus, you will immediately know lah kalau kamu dah mahir. Tapi kalau kamu tak fasih lagi with the language of chemical equation, buat tulis half equation. Fe2 plus in the end jadi Fe3 plus. So you work out the math. Kenapa, macam mana 2 plus, the charge 2 plus here boleh jadi 3 plus. So you must think dalam what happens kalau kalau dia in terms of losing and gaining electron. So kat sini saya tulis dia lost an electron. So kenapa dia jadi macam tu? Because this is, saya tulis dalam ni charge dia, okay? The charge from 2 plus dia jadi 3 plus. So kalau saya kata kat sini dia lost electron, meaning dia akan tolak negatif 1 n electron. So dia hilang sebiji electron. So kalau 2 tolak negatif 1, jadilah 2 tambah 1. Jadilah 3 plus. So that complies with the logic yang saya cerita tadi. Kalau kita kehilangan sesuatu yang negatif, kita akan jadi semakin positif. So daripada 2 plus jadi 3 plus. So that means iron here lost an electron. So kalau something loses an electron, that means they undergoes oxidation process. So that leaves us with steric here, confirm lah dia akan undergo reduction process. Dia akan terima elektron daripada iron tadi tu, Fe tadi tu. So daripada Ce4 plus, you verify your finding, your discovery tadi, Ce4 plus, tulis ya, Ce4 plus tambah 1 elektron, dia akan jadi Ce3 plus. Okay, because pada math point of view, tambah 1 elektron, jadilah 4 tolak 1, jadilah that's why jadi 3 dekat sini. Okay, so that is how you kamu verify siapa yang undergo, kamu identify siapa yang undergo reduction process dan siapa yang undergo oxidation process. And that is basically how redox titration works, by the transferation, by the transfer of electrons. Okay, so this is the setup is the same. Setup of any titration, redox titration ke, precipitation titration ke, acid-base titration ke, kamu mesti perlukan burette, conical flask. This is the titrant, standard solution, and this is the titrant, the sample solution. Okay, so this is the setup kalau kita nak buat redox titration of steric ammonium sulfate dengan ferrous sulfate solution tadi tu. So kalau this is our ferric and this is our ferrous solution. So if we masukkan drop by drop of ferric sulfate ke dalam this ferrous solution ni, the electron from ferrous solution will go to these droplets yang kita dah tambah ke dalam this conical flask. So at a certain point, kita akan reach equivalence point and then kita akan detect the end point and we will stop titrating and we will record lah the whatever volume we stop at. Okay, so kita akan stop the titration sama macam acid base titration. Kita akan refer to end point dan juga equivalence by a color change. Sama macam acid and base. So how does this color change work? So it's a bit different than acid and base. Kita ada 3 jenis dalam redox titration. We have self-indicator, external indicator, and internal indicator. Okay, so the first one is self-indicator. So what is self-indicator? Just like the name implies, kita tak perlu add any other solution. The change in the oxidation state will bring a change in color. Okay, kat sini saya ada tulis. An oxidized form has one color and the reduced form has other color. So kalau saya ambil contoh this ferrous and cerric ammonium sulfate ni, kalau kita titrate ni, kita dah tahu Fe2+ tambah dengan Ce4+, producing Fe plus Ce plus juga. Okay, so kalau kita titrate using this ferrous solution ni dengan cerric sulfate ni, kalau kita nak tahu when is the end point, kita tak perlu add any other indicator solution. Why? Because the change in oxidation state, the change in this electrical charge ni, dia akan bring a change in color to the solution itself. For example, ferrous Fe2+, warna dia adalah macam biru hijau-hijau, greenish blue. Tapi bila the lost electron, dia akan jadi a bit yellowish green. This is without any indicator solution. Okay, because the punya state, it is a different thing. Fe2+ and Fe3+ is dia masih lagi iron, tapi dia a different oxidation state. So it's a bit different. Dia punya electron structure dalam atom tu dah berlainan. And due to the change in the atomic structure, electron punya structure, dia punya physical property is also affected by the change of color. Okay, so kalau kita dah all the Fe2+ has reacted with the Ce4+ kat sini, bermaksud dia dah transfer all of its electron. Dah tak ada dah Fe2+ untuk transfer electron. So meaning Fe2+ ni dah habis lah. Okay, all the electrons are available from Fe2+ dah habis untuk diberikan kepada Ce4+. So we know that is the equivalence point. So we know that is the end point. So bila dah jadi yellowish green, that's it lah, we stop titrating. So that is an example of self-indicator. Kita tak add any other solution before we begin the titration, because we know, kita refer lah, okay, kalau kita nak titrate iron Fe2+ ni, ferrous solution, does it have a different color kalau dia dah change oxidation state? Buka lah pharmacopoeia, any other journal, you can even Google. Okay, in fact, in one of the videos yang saya attach dalam Google Classroom about redox titration, ada tunjuk change in color of different oxidation states. So you can watch the videos for better viewing. Kalau saya share sekarang ni the pixelated ke sangkut-sangkut. Alright, so that is the first type of indicator. The second one is external indicator. This is not widely used because it's not accurate. So how does it work adalah kita akan begin titration dulu without adding any other solution macam phenolphthalein in acid-base titration. Tetapi at a certain point, katakanlah we have titrated 10 ml of the standard solution into the sample solution. So kita tak tahu lagi kita dah reach equivalence point ataupun belum. So we take a small part. We use a dropper, kita ambil a small bit of the sample solution dan dalam conical flask tu, take it out, put it in a indicator solution outside. We have another beaker outside, take a small bit of the sample solution yang dah kita dah titrate 10 ml tadi tu, letak dalam beaker with the indicator. And then kacau-kacau tengok ada color change ataupun tidak. Okay. So the reason why this kita buat kita mix dekat luar is because masa tu this is an old method. The internal indicator solution belum lagi develop. So we do not know the existence of internal indicator. So they mix outside. Okay, so this is not accurate macam saya cakap tadi because kalau kita stop dekat 10 ml, okay, we have titrated 10 ml. So kita take a small bit, mix dekat indicator. Mix indicator. So kita kacau-kacau tengok no color change. So kita teruskanlah lagi titrate. So kita titrate another 10 ml dekat 20 ml. Kita stop titrate and then mix with indicator. Tengok ada color change. The color has changed. So how do we know this color change is at 20 milliliter? Maybe it's at 15 ml. Maybe it's at 11 ml. Maybe it's at 17 ml. So we don't know for sure. So bila the color change happens at the time kita check though, maybe it didn't happen at this point. Maybe it happened at this point. Maybe at this point. Maybe at this point. There's no way to know for sure unless kita repeat the titration, kita stop dekat 11. Ada color change ataupun tidak. Kalau tak ada, kita stop dekat 15. Ada color change ataupun tidak. So that's why it is not widely used. Lecture and it's not accurate. Okay. And lastly, internal indicator. Ini penggunaan dia sama macam phenolphthalein, methyl orange, methyl red dalam acid-base titration. We add the solution, we add the indicator solution before we begin the titration. Okay, but the difference is kat sini kita guna O-phenanthroline, ferrous complex, ferroin solution, 110 phenanthroline, diethylbenzidine. So these are the names of the indicator for internal indicator for redox titration. So for example, the O-phenanthroline ferrous complex, the color change is from bright red in color to blue in color. Okay, so that's one example for O-phenanthroline ferrous complex. And the application. So the application for redox titration, we test kalau ubat-ubat yang kita nak test tu mengandungi different oxidation state. Okay, contohnya macam ascorbic tablets, ubat vitamin C, PCM, kita nak estimate the amount of ferrous, ini pun ferrous, chlorpromazine tablets. So these are the examples of pharmaceutical drugs yang kita guna untuk test redox titration. If the substances that we want to test can easily transfer the electrons, it is best to use redox titration because this is how it the thing that we want to test to kita boleh biarkan dia bertindak balas with our standard solution. Okay, so let's take 5 and then later kita akan sambung with precipitation titration. Okay guys, I'm back. Sorry lambat sikit. Before we continue with our lesson, please join the quizzes as I share at screen right now. The link is in the chat room. Kalau tak boleh join tak apa, this is not graded. You can just tengok screen. Alright, so saya start dulu. Ish. This. Oh. Okay, don't mind. Dia punya ni slow sikit sebab ramai sangat. Ramai pula kan. Wah, betul semua. Okay. So, thank you yang dah habis for participating. Kalau top 30 habis, kita akan kita akan stop the quiz. It's just a fun quiz to refresh. Ini tak bergerak ni sebab internet saya bengong ke. Let me refresh. Okay, betul lah, semua dah habis. Alright, so saya end dulu apologies bagi yang tengah duduk menjawab ni kat bawah-bawah ni. And saya pun tak tahu macam mana kamu tahu banyak sangat. Nak tengok saya orang jawab apa. Okay, so most of you. So the right answer is this one lah. Abdul Sayyar. Bukan L. That's the most correct answer. You say go by already. Okay, next one. Do I have not anymore? Macam mana? Mantap ni kan? Teaching, so I started teaching at 2016. So it has been 5 years. December tahun ni cukuplah 5 years. Something I do, sebenarnya semua jawapan betul. Semua saya pun nak edit. This is a template for quizzes. Gardening pun saya suka, hiking pun saya suka. So, just forgot that. So I graduated, ramai pay attention pun lah. So I graduated from USM with the Chemical Sciences Bachelor's degree. This is also true, saya pelik macam mana ramai tahu. Saya dah beritahu kan? Saya dah lama tak jumpa kamu 2 tahun. So this year, I just enrolled in September this year as in a master's program at UC. I got sponsorship. So I'm also a student just like you. That's it. Thank you for participating. So dia nak bagi lighten up the mood sikit. Later in the end of the class, I nak try another assessment. So that's the proper quiz lah. Relating to our module. Alright, so kita nak sambung our lesson. Nak habiskan Precipitation Titration dan juga Gravimetric Analysis. Let me share it. Okay, we're calling it up. Okay, so Precipitation Titration. Alright, what is Precipitation Titration? Kalau kita tengok dalam acid-base titration, we are observing the reaction between acid and base. Kalau kita tengok Redox titration, we are observing reaction between two substances exchanging electrons, transfer of electrons. Okay, one electron can go from one substance to another. That is redox titration. So what is precipitation titration? So from the name, daripada nama ada ni, oh sorry, saya lupa change. So from the name, kita dah boleh identify it is a type of titration that produces precipitation, the formation of insoluble precipitates, bahan mendakan yang tidak boleh larut. Okay, so kalau kita titrate anything and dihasilkan mendakan, and the color change comes from the reaction of the indicator and the mendakan, itu adalah sejenis precipitation titration. And it is also known as argentometric titration. Why? Because the reaction of precipitation titration ni, the most common type adalah the reaction between metallic halides dan juga silver nitrate. So this is referring to the type of reagents, type of substances yang terlibat dalam titration. So metallic halide ni bermaksud elemen metal dan juga elemen halogen. Contohnya kat sini adalah sodium chloride. Na is a metal, chloride in this case adalah halogen, group 17. Na group 1 is a metal. Silver nitrate is this one. Ag is silver and O3 is nitrate. So kalau kita titrate the reagent silver nitrate dengan sodium chloride, dia akan menghasilkan AgCl, iaitu silver chloride. And this silver chloride ni, kalau kamu perasan, in this chemical equation, dia ada tunjuk anak panah pointing down. That means it is indicating that this substance here is a precipitate. Okay, bila dalam solution, dia turun ke bawah. It's a precipitate, duduk dekat bawah dalam solution. Dia tak boleh larut. So the reason why So the reason why silver chloride is known, the reason why precipitation titration is sometimes known as argentometric titration, as I have mentioned here, kat sini, argentometric titration, it is because kalau kita titrate menggunakan silver nitrate, which is a common reagent dalam precipitation titration, dia akan involve silver, Ag ni, and Ag is silver. It is a very dense metal, elemen besi yang tumpat. If you take any types of metal, any type of silver yang kamu can find, you put it in water or any solvent, dia akan drop down to the bottom of the solution. That is because dia punya ketumpatan sangat tinggi, dia akan duduk di bawah. So dia tidak boleh larut, dia tidak boleh dilarutkan. Produce silver thiocyanate. So dia ada silver kat sini, dia akan menghasilkan benda. Ya?
Tadi Sir start
Oh, saya tak tahu pun saya start dekat mana.
Baru je.
Baru je. Okay, saya tak tahu saya start. So kalau saya sangkut ke start, please let me know. So I'll repeat again. So kalau kita use a different metal halide macam ammonium thiocyanate, ya, kita titrate dengan silver nitrate juga, kita akan dapat silver thiocyanate here. So silver thiocyanate is also an insoluble precipitate. Dia akan menghasilkan mendakan yang tidak boleh larut, as indicated by this arrow here. So kalau kamu download the PowerPoint version of this lecture note, this is an example of the titration lah. Pada asalnya the solution dalam video ni, and ni kalau nampak kuning ni macam kuning susu kan. Tetapi in the beginning of the titration warnanya macam clear yellow. Tapi as the begin titration, dia akan, as we add the standard solution into this sample solution, dia akan menghasilkan insoluble precipitate. Dia akan hasilkan silver chloride. Okay, so that's why silver chloride ni garam warnanya putih. So garam warna putih itu menghasilkan kekeruhan lah. So that's why warna dia jadi kuning macam susu ni. Okay, jago. Asalnya clear. So the indicators, how does the endpoint, how do we detect the endpoint, the equivalence point dalam precipitation titration ni? We have we have three different methods. So all three methods are developed by three persons: Moore's method, Volhart's method, Fajan's method. These are three different persons and develop the indicator untuk precipitation titration. The most commonly used adalah Moore's method. Kalau kita titrate silver nitrate dengan sodium chloride, kalau kita titrate silver nitrate dengan sodium chloride, dia akan hasilkan AgCl. Okay, macam dalam equation kat atas tadi tu. Okay, so kat atas ni saya scroll balik atas. So kalau kita titrate silver nitrate dengan sodium chloride, dia akan hasilkan silver chloride. Okay, so silver chloride ni is the precipitate, mendakan. So the thing with precipitation titration ni, the indicator tu dia bukan bertindak balas dengan the reagent, tapi dia bertindak balas dengan precipitate. Okay, so this is how it works. So the precipitate ni, AgCl ni, dia akan bertindak balas dengan indicator. So what is the indicator dalam Moore's method? Dia guna 2% potassium dichromate. This is the indicator. Lagi susah nak baca orang. Okay, dia guna 2% potassium dichromate. So I wanna, this is a side note, kalau kamu masuk dalam makmal, what does 2% mean? So kalau kamu masuk dalam makmal, kamu nak prepare this indicator solution, you go to the store, wherever you store chemical, which you find potassium dichromate K2CrO7. Kalau kamu nak prepare this indicator solution, kamu timbang 2 gram of K2CrO7 and then you dissolve in 100 milliliter of solvent, usually water. So you have 2% potassium dichromate solution. So this 2% here is an expression of concentration juga. Cara kita nak express kepekatan sesuatu larutan. Okay, so this AgCl, this precipitate here akan bertindak balas with this potassium dichromate. Saya demonstrate kat sini. Bila dalam solution, this AgCl akan dissociate, akan pecah jadi Ag plus dan Cl minus. Okay, so Ag plus ni akan bertindak balas dengan chromate from K2CrO7. So the indicator also dia akan pecah jadi K plus tambah CrO7 minus. So this is where this thing comes from. So the Ag from the AgCl, which is the precipitate, akan bertindak balas with the CrO7, and then dia akan form a brick red precipitate, Ag2CrO4. Okay, so this is the difference between precipitation titration dengan acid and base and redox titration. Dia punya endpoint tu bukan kita kenal pasti from the reaction between the indicator and the reagent, tapi between the indicator and the precipitate. So that's why it is important that we understand the difference. Yes, okay. So the same thing like applies untuk all the other methods. Kalau contohnya Volhart's method, the titrate between different things, silver nitrate dengan ammonium chloride ataupun ammonium nitrate. Kalau kat sini dengan sodium chloride dengan silver nitrate. Tapi kat sini silver nitrate sama, tapi kita titrate dengan other things. Ammonium chloride here, ammonium nitrate. So kat sini dia suruh guna, kita suruh guna this here.
Sir,
So dia akan, yes?
tu start lagi.
Oh sorry.
Baru je.
Kena lagi. So kat sini dia akan the color change akan sama juga jadi brick red precipitate, sama macam Morse method. The color change will be brick red, warna merah. Okay, from my experience, kalau saya buat titration dulu, dia akan jadi not exactly macam brick red, macam merah butter, tapi dia nampak macam teh ais, teh susu yang pekat. Okay, the joke was dia nampak macam Sungai Kelang dulu. That's what everybody says. Kalau kamu boleh bayang air kat Sungai Kelang, ataupun kamu just bayang air banjir ke, air macam teh tarik, rosak pula nak minum air teh tarik. So, tapi basically that's what the colour looks like lah. Okay, teh yang warna merah tu dia change jadi warna macam keruh-keruh, sangat keruh. That's why those examples the joke work. So kat sini untuk both method, Morse method ke Volhard's method, the colour change akan jadi red precipitate. The precipitate tu asalnya warna putih. Kalau solution tu warnanya putih akan nampaklah precipitate tu warnanya putih. Tapi kalau solution tu warnanya kuning macam dalam the first video tadi, precipitate tu akan nampak macam warna yellow. Tapi warna yellow yang keruh. So lama-kelamaan kalau kita titrate with the indicator, the end point akan reach, kita akan reach the equivalence point and the color will change from whatever color we started with jadi warna brick red precipitate. Okay, so the mechanism is still the same. Precipitation yang bertindak balas dengan indicator, bukan the reagent, bukan silver nitrate, bukan ammonium chloride. Okay, the precipitate AgCl. And lastly, Fajan's method, titration of silver nitrate dengan potassium chloride ataupun NaCl. So this is not what they use anymore. I'm not sure why, saya pun tak pasti. Tapi saya dapat ni from previous lecture note. Tapi saya pun tak pernah guna fluorescein ni. Masa saya kerja as a chemist dulu. Saya pernah guna these two method kat atas ni. Ferric ammonium sulfate as indicator saya pernah guna, potassium dichromate saya pernah guna. Fluorescein not so much. Bila saya agree with this, tapi saya tak sure kenapa. Okay, and dia punya color change also the same, red color precipitate, sama juga. Okay, so these are the three indicator solutions yang ada dalam precipitation titration. 0.1% fluorescein, ferric ammonium sulfate ataupun ferric nitrate, and 2% potassium dichromate. Okay, and that's it untuk the three types of titration. Okay, so kalau kamu nak verify, kalau kamu nak ulang kaji, what do you need to know about the types of titration adalah first, you know the names of all the three types of titration: acid base, redox, and precipitation. Kemudian kamu mesti make sure kamu faham how it works. Macam mana acid and base titration works. So they work by acid and base neutralizing each other. Sekejap, kaki saya kepas, duduk lama saya. Saya berdiri sekejap. Redox titration, it works by one substance transfer electrons from to the other. Okay, redox titration works by the transfer of electrons between the two reagents. And precipitation titration, they produces precipitation, and the precipitates akan indicate the equivalent point. Okay, so that's how it works. And lastly, kamu mesti ingat dia punya applications. What are the applications of redox titration, gravimetric redox and precipitation titration? So so that brings us to this slide here. Kalau kamu nak test anything yang mengandungi chloride, you want to estimate the amount of chloride yang ada di dalam sesuatu ubat kamu tu. So kalau kamu nak test sodium chloride, potassium chloride, thiamine hydrochloride, mustine carbromal, kamu boleh gunakan precipitation titration because the chloride yang ada dalam ubat tu akan bertindak balas with our standard solution, which is silver nitrate. So Ag nitrate NO3, this is our standard solution lah, standard. So kalau kita titrate sodium chloride with silver nitrate, dia akan produce AgCl. Kalau kita titrate potassium chloride with silver nitrate, dia akan producekan AgCl juga, which is our indicator. Kalau titrate dengan thiamine hydrochloride, dia akan producekan AgCl juga. So the same applies untuk semua. Okay, so basically it is used to estimate the amount of chloride in certain pharmaceuticals. Okay, so let's power through this last topic here, gravimetric analysis. So dalam this subtopic, gravimetric analysis ni penggunaan adalah sama juga macam titration. Kita nak determine the amount of something in a mixture. So the drugs that we use, yang kita manufacture, ubat-ubatan, tablets are a mixture. Okay, dalam tu mengandungi API and other ingredients. So kalau contohnya macam titration, kita nak determine the amount of quantitative analysis. Sekejap, saya dengar ada orang nak masuk. Oh, tak ada pula. So kalau kamu Google the word gravimetry, maksudnya the definition is the measurement of weight. So there will be weighing involved in the steps of gravimetric analysis. So a continuation, kalau saya lukis kat sini. Okay, as I mentioned tadi, dalam ubat kita tu is a mixture. This is a tablet. So dalam ni ada API, ada bahan X, ada bahan Y, ada bahan Z. So katalah kita nak determine the amount of bahan Z sahaja. So sometimes we can do this with titration. Okay, kita boleh pilih lah which one yang will work best, yang akan bertindak balas with Z ni. So kita titrate guna that method, kita buat just M1V1 equals to M2V2, calculate the concentration. And then boleh cari dia punya mass, berat dia berapa. Tapi sometimes ada certain things doesn't work with titration. So gravimetric analysis is another option. Okay, so that's why saya tulis kat sini, dia involves the separation of constituents. Sama macam titration, kita nak separate bahan Z ni for example. So kita nak separate dia from the other ingredients, kita nak estimate berapa dia punya amount. Okay, so how do we separate this? Kita akan hasilkan an insoluble compound. So kita akan mix it with another reagent, another solvent yang hanya akan bertindak balas dengan bahan Z ni sahaja. So dia akan tarik dia keluar, menghasilkan precipitate, menghasilkan mendakan. Okay, and then kita akan follow beberapa step lagi, and in the end kita akan timbang berat. So gravimetric analysis, kalau kita bandingkan dengan titration, it is slow, tedious and time consuming. Leceh lah, okay, to be blunt. But sometimes titration does not work, kita guna gravimetric analysis. Okay, and this is only applicable to those substances which form a definite metallic compound, macam dalam precipitation titration tadi tu. Dia kena ada bahan yang akan bertindak balas dengan yang akan menghasilkan metallic compound, bahan yang ada metal, yang boleh form a bond with metal. And also dia tak mengandungi volatile metal, bahan yang mudah meroap. So how do we perform this analysis? So these are the steps, ada 7 langkah kesemuanya. So let's take a look at the first one. Kita akan timbang dulu. So if you have ubat, katakanlah tablet, and as macam biasa kita akan refer to pharmacopoeia macam mana nak perform each product. Tapi katakanlah for example kat sini kita tengok produk G, nama dia produk G. And then kita tengok pharmacopoeia, kata okay, untuk buat gravimetric analysis untuk produk ni timbang 5 gram. So kita ambil tablet tu, kita grind jadi powder, weigh 5 grams of the tablet, of the powdered tablet. Okay, and then kita akan mix that powder of the tablet dengan a solvent yang akan menghasilkan mendakan. Okay, so in this example dia bagi contoh kalaulah kita ada bahan yang kita nak detect tu adalah sulfate. Okay, bahan yang kita nak detect tu adalah sulfate. Kita akan mix the tablet. This is the tablet. This is the tablet. Dalam tablet tu mengandungi sodium sulfate. So kita nak estimate the amount of sulfate. So kita mix the tablet, powder tablet dengan barium chloride solution. So bila kita mix, dia akan menghasilkan barium sulfate. This is the precipitate. Sama lah kalau macam ubat tu mengandungi sodium chloride. So this is the tablet. So bila kita mix with silver nitrate, dia akan menghasilkan silver chloride. So kita boleh estimate the amount of chloride kat sini berapa. And also kalau in this case, kita boleh estimate the amount of sulfate kat sini berapa. Because this is the mendakan yang terhasil ni. Okay, so kita dah extract, kita dah tarik dia keluar from all the other mixture ingredients. So after we have formed the precipitation, kita akan filter. So just use a beaker and a filter funnel and a filter paper, tuang je kita punya solution tadi tu. After that, kita akan wash, kita akan cuci to make sure that there's no residue left on the precipitate. Kita nak bagi dia bersih daripada other impurities. Kemudian kita akan keringkan dia, masukkan dalam drying oven. The temperature varies, but usually from 110 to 120 degrees Celsius. And then kita akan ignite. So ignite ni adalah proses di mana kita nak buang any other minerals ataupun metals that could still be available on the precipitate. Okay, the mendakan yang kita hasilkan tadi tu, kita nak dia suci bersih from other things. Kita just nak measure the bahan yang kita extract keluar saja. Kita nak measure sulfate ni, kita nak measure chloride ni. So we don't want any other things yang masih lagi boleh terlekat. Yeah, kita tak tahu, maybe ada, maybe tak ada. So to be sure, we just do it. Okay, to eliminate the risk of them still be available on the precipitate. To go up to this temperature because all those metals, minerals can only be ignited at very high temperature. Okay, so kita refer tu lah pharmacopoeia, what's the temperature yang kita perlu set. Certain substances ignite at different temperature, so kena refer to pharmacopoeia. And lastly, the last step is kita weigh, timbang. So the logic is, kalau lah initially it was a tablet kan, dalam tu mengandungi API, bahan X, bahan Y, bahan Z, and then we go through all this process just to extract bahan Z sahaja. So the logic is, kalau ini adalah 5 gram, the final weight should be less than 5 gram, a lot less than 5 grams. Okay, because kita dah buang dah bahan-bahan lain, kita dah eliminate, kita dah wash, kita dah dry, kita dah ignite. And then the idea is it should be left with only bahan Z saja. Okay, so kalau kita ambil contoh from this slide, so in the end it should be just barium sulfate saja, BaSO4 saja. It should be, kalau kita ambil this one, it should be AgCl saja. After dah wash, after dah dry, after dah ignite, ini saja yang tinggal. This is the precipitate. Kita nak precipitate itu sahaja. Okay, so the final weight should be a lot less than the initial weight. Katakanlah, this is the formula macam mana nak kira, macam nak report the data. Katakanlah the final weight is 5 milligram. Okay, so kita ambil 5 milligram tu bagi dengan 5 gram, darab dengan 100. And still you have to convert this to grams. Sorry, so 0.05 lah, 1, 2, 3, 0.05, my bad, 0.005 divided by 5 darab dengan 100, dapatlah 1, 2, 0.1%. Okay, so the barium, kalau saya ambil contoh bahan Z tadi tu, bahan Z is only 0.1% of the 5 gram sample. Okay, sangat kecil. So kalau the specification, kalau nak tengok whether the drug passes or fail the test, kita kena refer pharmacopoeia lah. So katakanlah kita refer pharmacopoeia untuk produk G ni, bahan Z should not be more than 0.1%. So kalau kita dapat 0.1%, pass lah the test. Okay, so this is how we report gravimetric analysis. Kita report in the form of purity, percentage purity, ketulinan. So the applications of gravimetric analysis is to estimate these things. Kita nak tengok the amount of aluminium, kita nak estimate the amount of magnesium, kita nak estimate the amount of sulfate ataupun silver. So if you notice, all these things adalah metal. So if we have like the presence of heavy metal in our drug, kita tak boleh nak eliminate in the formulation process, kita tak boleh nak buang. Tapi we allow a small percentage dalam kita punya ubat. So contohnya kat sini 0.1% saja, very very small. So kita mesti detect and report for the safety of the consumer lah, orang nak makan ubat. Okay, so these are the applications, any ubat yang mengandungi these things. Okay, so that's it untuk chemical analysis chapter 3. Do you have any questions? Tidak ada. So kalau tak ada, itu sahaja kelas for this morning. Thank you. Kalau yang join lambat, before saya share the attendance, please get the link from your friends. Ada dekat dalam chat room. Don't forget to sign in to today's attendance. Okay. So thank you. Nanti saya akan kita dah habis 3 chapters. So saya tak sure saya dah beritahu kohort kamu ke kohort lain. Kita akan start buat your midterm test. So let me check your calendar. My calendar, your pula. Saya belum beritahu kohort yang lagi, itu kohort lain. So the date for your test is next week on Friday juga. Okay, so the quiz macam saya beritahu earlier in the semester, kita akan buat menggunakan quizzes. Cover from chapter 1 to chapter 3. There will be 30 questions and all of them will be MCQ, multiple choice questions. Tetapi saya kita tak akan buat at a certain time. Okay, saya akan make the link available for 24 hours. You find the time yang kamu boleh buat test tu. Maksudnya kamu free lah, kamu tak perlu buat kerja, tak ada gangguan from anyone. Pilih je mana masa kamu free, tapi within the 24 hours. Saya kena set limit lah because this is test. This is the okay, saya akan set the time for each question accordingly.
Start tadi.
Okay, kamu dah dengar quizzes kan? So saya akan buat test tu menggunakan quizzes, tak ada specific time, tapi the link will be available for 24 hours. So kalau saya kata start, kita akan buat test hari Jumaat depan. So the link will start from 8 pagi hari Jumaat tu sampai 8 pagi hari Sabtu. So 24 hours. Okay. So kamu carilah masa yang kamu free untuk kamu buat test tu. Ada 30 soalan, kesemuanya MCQ, cover from chapter 1 until chapter 3. Kamu boleh kalau nak study boleh tengok tutorial. So most of them will be based on the tutorial. Jangan lupa tengok videos and lecture notes lah. Semua material yang saya gunakan dalam lecture kelas ni. Okay. So Jumaat depan who is this? So any questions? Kalau tak ada, that's it for the class today. Thank you for participating and joining. See you next week.
Terima kasih, sir. Thank you, sir.
Thank you.